Okay, so let's look at some steps of how to solve these, how to do the SOHCAHTOA. And you got to be careful with the SOHCAHTOA thing because the H is silent in all of them. Okay, or the first two there that it's in. So steps to solve right triangles, and that's what some of your homework is going to ask you to do, is to just solve a triangle, solve a right triangle. So first of all, we're going to highlight the angle that we're talking about. Okay, then you're going to label the sides based on that, which one is opposite of that angle, which one is the adjacent to that angle, and then of course the hypotenuse. And then depending on which one you're being asked to use the SO, the CA, or the TOA. Okay, so find the ratios in reduced fraction form is what the instructions say. They're asking us to find sine of angle M. So that's the critical part, is that it's angle M is what we're looking at. Okay, and so as we mark angle M, now we need to figure out which one is the opposite, which one is the hypotenuse, and which one is the adjacent. Okay, so the opposite is 4 on the bottom there, opposite angle M. The hypotenuse is the 5, the longest side of the triangle opposite the 90, and the 3 is the adjacent. So the rule for sine is opposite over hypotenuse. That's the ratio that sine represents. And so we take the opposite side and put it over the hypotenuse. That's what the sine ratio is. And so if we fill in what that would be from this particular triangle, it would be RP is the opposite and MP is the hypotenuse. So we fill in those amounts and we get 4 over 5. So the sine of angle M is the ratio 4 to 5. All right? Tangent of angle M. So still looking at the same angle, so the pieces still stay in the same order, all that. The tangent, if you look at the SOHCAHTOA, the tangent is opposite over adjacent. Opposite over adjacent. So we're going to go to, again, comparing angle M. The opposite is the 4 down there, the RP side, and the adjacent is the side right next to it, the MR side. And so we would go 4 to 3 for this particular example. Okay, so the tangent of angle M is 4/3, ratio of 4 to 3. Last one, let's look at cosine. The cosine of angle P, though, changing it up on you here, got to pay attention to the angle. So now we're looking at angle P, and the cosine is the adjacent over the hypotenuse, the CA part in SOHCAHTOA. Okay, and so the adjacent to angle P is RP, which is 4 in this triangle. The hypotenuse is 5, and so the adjacent over the hypotenuse is 4 to 5. So the cosine of angle P is 4/5 in this example. All right?
All right, so now we're going to actually get to where we're going to have to calculate some things out here. And this is to find the ratio as a fraction and decimal to the nearest 10,000ths. Now, when I look at this triangle, I already see you could basically do some things we've already done here. But
Right.
But we're going to use sine anyways, guys, to figure this out. Some of you may look at this and say, oh, yeah, that's a 30, 60, 90, just because I see double the short leg to make the hypotenuse, and I see a 5√3 on the long leg. That, you know, we can use 30, 60, 90 to know that F would be 30, U would be 60, and N would be 90. But let's go back, and you can see then how sine is going to give you the exact same answer.
Right.
You know, when we work through
If
this.
it was a different triangle,
Yeah,
this is going to work.
Yeah, so you can kind of relate what you know about 30, 60, 90s to how sine works, guys, how the sine function works. So here we go. So basically, we're going to highlight that angle first, angle F, because that's the angle we're talking about. And then we're going to think, okay, we're talking sine, so what do I need? Well, sine is part of SO in there, so I need the opposite and the hypotenuse. And it's going to label all three, but we just need O and H because we're talking sine, which is probably going to fly in right here. And then so the opposite of angle F is 5. The hypotenuse is 10, so I just make a fraction out of that. And you can reduce this if you want, but now you're going to start to see a little bit of your algebra here. Or, no, they just want the ratio. And so we're just going to change that to the least we can here. So 5/10 becomes 1/2. And as a decimal, we know that 1/2 is the same as 0.5. And I guess I was misled here. I thought we were going to actually figure out what the angle F would actually be.
Oh, not yet.
Not yet.
There.
So sorry about that, guys.
Yeah,
so we're going to get to that anyways. But you could it's important to know that angle F is 30 degrees anyways. But
yeah.
But you could do something with sine, guys, with that 0.5 to figure out that F is 30 degrees.
Right.
But we're going to get to that later.
Yeah, we'll catch that.
So now we want the tangent of U. So now we're going to highlight angle U here. All right. No, they didn't highlight it, but we want an angle U. So now we're going to go back. Let me just back here. So to do the tangent of U, guys, we need the opposite over the adjacent. So now the hypotenuse is out. And to me, tangent is typically the hardest one at first because you can't count on the hypotenuse.
Right.
And so you got to know which one's the opposite and which one's the adjacent. So the opposite, remember, the angle always opens to its opposite. And so the opposite is 5√3, so it's going to be 5√3 over 5. And just as we did with special right triangles, we can reduce that because 5 is rational on top and the bottom, so we're going to reduce that down so we get root 3 over 1, or just root 3. And when you plug in root 3 to your calculator, you get approximately 1.7321. Now, notice that it goes back 4 decimal spots here.
Yeah, that's critical.
Yeah, they're going to have you do that every time. It's going to always tell you to go back to the, what is that, 10,000ths? And so that's what you're going to do, guys. So just get in the habit of going all the way back there.
Yeah, trig ratios are always taken to 4 decimal places. It's just one of those rules of math.
Yep.
Their trig is always done to 4 decimal places. So.
Okay. And so now if we want to find the cosine of f, all right, so now we're going to look at angle f. And so now cosine is a little bit different because it's the adjacent over the hypotenuse. So once again, hypotenuse gets to come back in, which is nice because you know that 10's got to be on the bottom. And then the adjacent is going to be 5 root 3. So now we get 5 root 3 over 10. And so we can reduce that 5 and the 10 to 1/2, so you're going to have root 3 over 2, which is still good because I don't have a radical on the bottom. And then all we got to do is go root 3 divided by 2, and you get approximately 0.8660. Include the 0 in there, guys, because they want 4 back.
Yeah.
Okay?
And we could have written the 0.5 as 0.5000, but we do tend, when it's just 1 decimal place, we tend to just stop it there.
That's true.
It should be to 4 decimal places, technically.
Yeah.
So.
A lot of these are irrational. They're going to go on forever,
Right.
but since 0.5 stops right there,
Yeah.
that's
stop
it. Yeah.
Yeah. So.
All right, now the sine of u. So we're going to look at the sine of u now, and you're going to see, well, let's see what happens here. You might notice something. So if we look at the sine of u is going to be the opposite over the hypotenuse. So when I go to plug things in here, I get 5 root 3 over 10. Look at the one right above it. It's also 5 root 3 over 10. So that's going to reduce down to root 3 over 2, which is approximately 0.8660 again. So hopefully you're able to make a connection there that some of these rules are interchangeable if you set them up correctly.
Catch the pattern of what's going on.
Remember, guys, there's only 3 angles in a triangle. One of them is 90, so the other 2 have got to be a combination of the same thing. They're not automatically going to change because we're using a different trig function. It's going to be 30 and 60 no matter what.
Yeah.
So that may come up in a different way just depending on which function you use.
Right. The other 2 angles are always complementary, and there's a relationship between sine and cosine, so see if you can catch that pattern as we work through the chapter here. Okay, same types of examples here, except that now we're finding, we're given a specific angle measure for this. And so if we're trying to find that side over there, notice what's happening. And when we were using Pythagorean's theorem, if you were given 2 sides of a triangle, you could find the third. Now if we're given any one side of a triangle and one angle, besides the right angle, we can find the other sides of the triangle. Okay, so we want to find x here. Well, if we look at the 40-degree angle, the side x is the opposite from that one. Okay, the other angle, the other side that we're given is the 20, and compared to that angle 40, it is the adjacent side. And so you have to figure out which trig ratio has those 2 sides included in it. Well, the opposite over the adjacent is tangent. And so you just need to have these things memorized. You're going to have to get to the point where you have that memorized. And so that's the equation that we need to set up here, is that we would take the opposite over the adjacent, the x over the 20, and that's going to give us our tangent equation here. So the tangent of the angle, tangent of 40, is the opposite over the adjacent, which would end up being x over 20. And so this kind of goes back to our proportions from last chapter a little bit to solve that. You're just going to multiply both sides by 20, okay? And so it ends up being 20 times the tangent of 40. Now you don't multiply the 40 by 20. The 40 is an angle. The 20 is a whole number. It goes out in front. Again, the tangent is an operation, kind of like a radical. And so you keep it separate, okay? But you can plug that into your calculator now. And so if we plug the tangent 40 into our calculator, and we'll talk about that in class, how to get your keys, the right way to do that, times 20 gives you 16.7820. But here's an example of you cannot do this problem without a calculator. You have to have a calculator to do that. So if you still haven't gotten one, you got to get one.
Typically, a lot of guys too on the state test, they're not going to necessarily have you solve for x. A lot of times they just want to see if you can get to that x equals 20 times tan 40. A lot of times just, do you know how to convert a trigonomic function more than anything else.
Or sometimes they'll give you a little table of some of the tangents, and you have to figure out which one you're going to have to use. So, yeah. Similar question. It's just that now we've switched the angle to the other side, and so does that change the trig ratio we're going to use? Well, we're using the 60-degree angle now. Okay, we could actually use 2 different no, I'm sorry, are still going to use tangent here because the opposite side is 20, the adjacent side is x. We need the trig ratio that uses opposite and adjacent, and so again, we're going to use tangent here. Same example as the one before. Tangent of 60 is the opposite, 20, over the adjacent, x, but now the variable's on the bottom. So that does make this a little bit more complicated to solve. In order to solve that algebraic equation, you're going to multiply both sides by x, and you're going to get, and then divide both sides by the tangent, 60. So if you multiply by x, you're going to get x tan 60, divide by the tangent 60, and you're going to get 20 over tan 60. Or in other words, the x and the tan 60 switch places to solve that kind of an equation. So you got to remember some algebra there. And again, plug that into your calculator, 20 divided by tan 60, and you're going to get 11.5470 for x. All right. Another example here, last one. We have 20-degree angle. We have the side right next to the 20-degree angle, so that would be the adjacent side, and we have the hypotenuse, the longest side. And so which trig ratio uses adjacent and hypotenuse? Cosine. So we need the cosine of 20 degrees is going to equal the adjacent y over the hypotenuse 12. Solve it the same way as the first example up here. Multiply both sides by 12. You're going to get 12 cosine 20 is equal to y. If you plug that into your calculator, you're going to get y is equal to 11.2763. All right, I know that's a lot in a shorter period of time. These are definitely things that you have to practice and just do to get.
And it's just giving you guys some insight as to what's coming.
Yep. Okay, so we will work on several different examples of being able to use the trig ratios. Okay, we'll see you guys in class.